Good morning, good afternoon, good evening. Welcome to today's Cluster API office hours, weekly office hours. Today is Wednesday, May 31st. Cluster API is a sub-project of SIG Cluster Lifecycle. We're part of CNCF. We're kind to one another. Please raise hands to speak and let's have some fun. All right, at the beginning of every meeting, we by custom pause for folks who are new or for any reason whatsoever to raise hands and say hi, introduce yourself. So I'll do that now.
Yeah, I can say hi. I think it's first time I joined the office hours. I have met some of you I know at KubeCon this EU. I'm contributing sometimes, but working mostly on the Metal Cube provider and OpenStack provider for Ericsson. So hi, I'm Leonard.
Welcome, Leonard. Go ahead, Chris.
Yeah, I've been joining for a couple of weeks now. I don't think I've formally introduced myself though. I just wanted to kind of say hi. Name is Chris Kim. I work at Sousa Rancher, and I'm a consumer of Cappy currently, but looking to try to help maintain the actual project.
Sounds exciting. New maintainers are always welcome. Welcome. Anyone else want to raise hands and say hi? All right, try to get my whole head in frame here. Okay, beautiful. Let's go to open proposal readouts. I actually know that I've got one. Looks like maybe I've got the only one. So I've got a to-do item here in the doc. I'll change the title to reflect the improved title for this CAPE. Thank you, Stefan, in particular, for doing a thorough review round. I think this one's almost ready to land. So we've got one LGTM. We'll probably wait for more, and then I would anticipate next week maybe we'll announce a lazy consensus deadline. So this is nearing completion. If you have any thoughts, opinions, please, now is your chance to influence the outcome of this proposal. All right. So now we will go into the agenda portion of the meeting. Looks like Fabrizio, you've got two, so I'll just hand it off to you for a little bit.
Thank you. So first of all, a really well-deserved shout out to the CI team. Kilian leading, Christian helping, and a lot of amazing folks doing the work. So we have, after a long time, we have a CI signal which is pretty almost green. There is only one test to get fixed, but this is because there was some change in latest kind images. So let me say it due to external factor. So great work. It is really amazing to see. To see this happening. This is what makes possible our releases. So it is super important. And with this, I also like to, we did in the last weeks, but the release team is not only chasing flakes, but is doing a job that is even more important, which is trying to share the knowledge about how to debug and fix issues in Cappy. And they are doing some really great sessions. I think every Friday. Is that correct, Kilian?
So they've been kind of informal and a little bit all over the place in recent weeks. Okay,
so those sessions are really valuable. I would really like to see people getting to the hoop. I would really like to see some new faces basically doing screen sharing and driving the debug session, because this will give the project the lifeblood to get a release out also in future. So thank you for the work done so far. Thank you for the work done for sharing the knowledge, and please, folks, step up. I stop a second to see if there is someone that want to comment on this one.
Can I just take an informal poll? Could you engage a Zoom notification if you're on the CI team? So we can all put faces to names. This is great work.
Oh, yeah, that
Thumbs up.
that's
What,
the,
I don't know what
Hmm.
Stefan raised his hand. Go ahead, Stefan. Or you just, is that your?
No, I wanted to comment on that. I'm not.
Okay, go ahead.
I'm just watching. Yeah, I just wanted to emphasize that it's really, really important. Basically, during the last release cycle, we saw that the CI signal was really degrading over time, and then we had like really 2 or 3 pretty hard weeks before the release to essentially fix CI, fix issues in our code, just somehow get it ready for the release. We're in a much, much better state today. But I think we really have to be careful that we can preserve that over time. And it's not guaranteed that basically like the same people who are doing this today can do it for the next release cycle. So I think we really need more people joining there, helping out, etc., so that we don't get back to what we had last cycle, basically.
Killian.
Yeah, I agree with everything Stefan just said. I think we said it before. But yeah, just on the question of who's actually on the team, just to shout out. It's Christian, Adil, who I don't think is on the call, Aniruddha, and Tobias are the other members of the team. So yeah, just thanks to everybody. It's been a pleasure to be on the team with you guys.
Cool. Looks like we've got a demo next. How much time is sort of budgeted for your demo, do you think, Fabrizio?
I think that 10 minutes will be enough, 10, 15 minutes, depending on the question. I try to keep it short. Stefan is running the show. If you can give comms to in, and then I will speak for the first part, and then Stefan for the second.
This is the point where you, the time where you give me co-host check. Check, still there?
Oh, I'm sorry, I've been muted. My inner monologue is just inner, I guess. I'm struggling to figure out how to do it with full screen. And I'm also struggling with how to
I think you can
exit full screen.
I think you can stop sharing if you want to. Then you probably end up in the screen before.
Let's see. These moments make me feel like I've become I'll say my dad, because he was doing this when I was a kid and I thought he was old and slow at stuff. So I'm getting what I deserve.
It should be, if you go to the participant list, you roll over Stefan's name. There should be a drop down with more, and probably it is there if I remember well.
Yeah.
Yeah, it should be there.
You're there. You're up, Stefan.
Okay, perfect. Let's see. This will stop another screen share. That should be fine. Okay, let's hope I share the right screen. So you should see a slide.
We're good.
Okay, then Fabrizio.
Okay, dokie. So quick recap from previous discussion. So we need a tool that will allow us to get a signal on copy working at scale. We are looking for something that can run either locally or on Prow. And long term, this should support cost testing, but it's long term. So we had a couple of discussions at KubeCon. The idea was to implement a mock cloud provider that worked just enough to keep copy happy and to scale without consuming resources. This provider is just focused on test copy KCP, copy BK, it does not support running pods. It's super simple. It's just the minimal things that we need. What we are going to demo today. First, I'm going to these two slides just to explain how the new provider works. Then Stefan will show a quick demo of the provider running locally, and also show how we are stepping up for observability to in copy, matrix, or whatever. Everything is necessary to find the bottlenecks when we are running a scale. And just okay, why we are doing this demo? Because what we would like to do after today proof of concept is we would like to start moving the provider under the test folder in copy, so we can collaborate on it, because there are folks like Lennart and Richard, which are doing similar jobs, and we agreed on this path forward, and having the coding copies, the beginning of our collaboration on this. And so at the end, we are going to ask for a +1 or for this move, or to set up a lazy consensus. But yeah, let's get into the demo. Could you move to the next one, Stefan? Okay. If you think to a traditional provider, what we have, we apply a bunch of YAML, then copy, start to work. The infrastructure provider controller start to work. All of these happen in management cluster, and then a machine gets created into the target infrastructure, into the cloud provider. And this machine not only is a piece of hardware, but it also where a Kubernetes cluster is going to be hosted. And so an API server pods show up, an etcd pods show up, and cluster API talk for this pod to do its own job. Okay, how can create this fake provider we were talking about? Could you move to the next slide? So the idea is that only go back one click, sorry. 1, 2 click. What happened?
That was wrong back button. Once again. Yeah, just send me a click. I'll wait for you.
Okay, thank you. Thank you very much. So what we are going to do is that a simple solution that work only in the management cluster. There is no cloud. What we are going to do is that first click is that when we create a VM, there is no cloud infrastructure. There is no hardware. So we just create a record in memory. It is okay. There is a VM in memory. And second click. But what happens is that since this VM is expected to host a Kubernetes cluster, we are going on also to create the resource that usually kubeadmin creates in the Kubernetes cluster. And so we are going to create the node, we are going to create an API server pod, we're going to create a etcd pod. All of these will be in memory inside the new provider, which has been called Goofy for now. And then as soon as we have this, the last click, what we are going to do is that inside this provider, the controller of this provider, we are going to create on the fly a new HTTP listener that will act as an API server and as an AT server, just reading for the things that exist in memory. So everything fake, everything in memory, just enough to make cluster API happy. And yeah, over to you, Stefan, for the second part. And thank you for helping me preparing this.
Yeah. Just see. 1 second. Just fighting with my tabs here. Okay, good. So what I'm going to do, so basically I have on my local machine, I've run tilt up. With tilt up, I basically deployed all the core providers plus GUI provider instead of another info provider. And based on that, I'm basically running more or less like a normal end-to-end test, but I'm deploying like one simple cluster, and that just in this specific case 400 times. So I'm creating like 400 clusters, And the YAMLs are basically looking like this. I won't go into details, but basically it's like the standard quick start with pretty much like, okay, here's a Goofy cluster, here's a Goofy machine template. It's all just empty because we don't have any configuration. But yeah, that's how you can imagine the cluster resource are looking like. So yeah, so I'll take this, create 400 clusters with that. I only have one screen shared, so I'm not showing kubectl, but next best thing. So I have it running until we have a few tools available, Prometheus for metrics, Grafana for dashboards, Grafana for logs from Loki, and also Parser for the profiler, but I go through them step by step. So the first thing that I want to show is basically, so I created those 400 clusters and what happened. So what you can see here, by the way, this one here is using the cluster API configuration for kubestate metrics. So we get metrics for our cluster API CODs. So the first thing I'm looking at is basically the phase of the clusters that we currently have. And what you can see here, basically I started somewhere with 0 here. I think we only have like one data point every 15 seconds or something. That's why it jumps from 0 to something. But basically I deployed all the 400 clusters. Then we had some in provisioning. Some are pretty much instantly in provisioned. And you see after like the first 2 minutes, the cluster object itself, we have 400 cluster objects which are provisioned. That basically covers infrastructure cluster, the cluster, and yep, only those two. Control plane is not included in provisioned here. If you look at the corresponding data for machines, it looks a bit more interesting. So basically, as soon as I deploy the 400 clusters, I'm also deploying like 400 control planes, one machine each, 400 machine deployments with one machine each. And what you can see here, so this one here is the running machines. So we're going from 0 to 800. And then if you look at, I don't know, provisioning, for example, let's take a look at all. Let's take a look at all. Basically, we deploy all those machines, and we have some in pending at the beginning. Runnings are just getting more and more. Then some of them are in provisioning over time, and overall, we end up with all of them running. So we are at a state where the provider basically works. We don't cover all use cases yet, so don't expect like, I don't know, that the upgrade works at this point, but that's something that we want to extend over time once we have the provider in the core repository. Our main thing that we want to focus on is basically like some sort of MVP use case. We can create clusters, we can create a lot of them, and we can figure out if core cluster API, including the Kubernetes providers, are performing as expected. Okay, so those are just really basic metrics. What we also did is build a dashboard. So we built this dashboard for scale tests, but I think it's generally usable for everyone who uses cluster API. And I guess usually it should also work for everyone who uses controller space and controller runtime. So in this dashboard, there should be absolutely nothing which is cluster API specific, except I forgot something, but I shouldn't have. So I would go over a few dashboards just to show like the kind of information that we have here. So what you can do on the dashboard is basically you have all pods running in the management cluster, and I'm just selecting like 2 providers, which is core cluster API and the Goofy provider. For some of the dashboards, you can filter down to specific controllers. So you could say, oh, I only want to look at metrics of, I don't know, the cluster controller or the machine controller. I'm not filtering that for now, but just FYI. Then, yeah, if you go further down, it makes more sense. Okay, so basic stuff. We see some sort of CPU usage, and I think what is a good takeaway here is that even though we are running like 400 clusters right now, basically, virtually, whatever, we don't need a lot of CPUs. So it's still under one core, those 2 controls together. I think so, like 2 or 3 CPUs should be fine just to run this whole thing, 400 clusters, which is like a huge improvement to what we can do with anything else that we have available. What you can also see is a similar result for memory. So even though the Goofy controller hosts 400 clusters internally in memory, we are at 1.3 gigabytes of memory, which is really nothing. So assuming core copy can do it, you can really get up to a few thousand clusters with the Goofy provider, assuming the core machinery can handle it. And I mean, that's the goal, right? To improve it over time to get there. So CPU memory, then a bit controller specific stuff. So I think one thing which is very interesting is one reason why things are getting slow if you have many clusters is because per default, we're only running 10 workers for each controller. So what you can see here is the number of active workers, which are just best, even if they're fully saturated 10. Here also like in percentage, depending on how much you actually have configured. And just first takeaway, basically you see that the machine controller, the cluster controller, machine set controller, they're really often at a limit. And what is very interesting is that basically the machine controller is staying at a limit. So even though everything is stable since half an hour or something, we still have the machine controller, which reconciles machines continuously, even though there's nothing to do. So that would be something that we could take a closer look and try to figure out if that is actually necessary and then improve. So I'm not going into every detail, just want to highlight a few. Then we have stuff like a reconcile metric, so number of total reconciles per second, then also filtered on by result. We can also take a look at how many of those failed, how many did requeue, that sort of stuff. Then next up, also very interesting, the work queue. So the number of items in the queue for our controllers. What you can see is basically here that our machine, the queue of our machine controller is like very much at a limit. So we have 800 machines, and at any given point in time, we have more than 500 in the queue. So that's probably not perfect. I mean, of course, our just running with 10 workers is definitely not a good idea, but probably also makes sense to take a look at how often the way we requeue machines. Because if there's nothing to do, we probably shouldn't continue to reconcile. So stuff like that, we can take a closer look. Then there are metrics around how long does it take to reconcile objects. So this metric here, for example, is if you look at how long it took to reconcile objects, that's basically the highest duration that you can see at any given point in time. So here's like, oh, we had a reconcile which took like 3 seconds. And for some reason, I didn't take a closer look how we have to filter down to one controller to get a useful. Okay, for some reason it doesn't work. Take a look at this one. Maybe that one works. Yeah, okay. And let me change the duration. I think maybe an hour is already not good. Yeah, here that looks fancy. So we also have histograms basically to see how many of the reconciles are taking how long. Basically, that's the amount of time that any given item is in the queue. So basically, if you look at this one, then we can see that if you look at all our items, they're at worst case like 10 seconds in the queue before they're getting reconciled. And then you can take a look at how many of them are reconciled how fast, or sorry, how many of them are how long in the queue. And that's the corresponding data for how long do we need to reconcile one of those work items. So yeah, just some rough high-level data on how quickly are we getting stuff out of the queue and how quickly are we reconciling stuff. Okay, almost done with the metrics. We also have something for outgoing requests from the client side. It's not that much data because control runtime is a bit careful about exposing too much metrics. So that's probably something where we want to improve the Goofy provider over time to essentially get server-side metrics for workload clusters. How often do we list nodes, write objects, stuff like that. And finally, Go metrics. So we have numbers for Go routines where you can figure out, do we have a leak or is it normal that we have like 2,500 Go routines for 400 clusters or not? No judgment at this point. Just showcasing the kind of questions that we should ask and improve, or 5,500 Go routines in the Copy core controller. And of course, memory. Do we have some sort of memory leak? How about garbage collection? How much time do we spend in garbage collection? That sort of stuff. And how much churn do we have in memory, for example? Okay, so those were the metrics. 2 to go. Next up, I'm not going into details. We showed this in the past. We also have our logs in Grafana, so we're shipping all the controller logs from the pods via Promtail into Loki, and then you can look at them in Grafana. And what we can do here is essentially, if we see, I don't know, this cluster is slow to create, we can essentially zoom in into this cluster and see what logs are we emitting for this cluster, and where do we waste the time essentially? Why are we not making progress with the cluster creation? And then, of course, while we do all of this, we probably will discover that we have a bit of a potential to improve our logs to essentially emit more information to be able to debug this sort of stuff. So just continuous improvement everywhere that we can do and once we try to get those large-scale use cases to work. And the last one, I don't know who's familiar with profiling. Basically, the standard thing with Go is in normal copy controller, you can set profile address, then you get an endpoint, and then you can run go to a pprof something, and you can see a profile. You can get a profile. And in the profile, you see stuff like how much time are we spending in which code, who is creating new Go routines, who is allocating how much memory. And there is an open source tool. I don't know how to pronounce it. I just call it Parser. And that tool is essentially continuously getting profiles for us and storing them internally. So it's only has very little setup. It's included in our tilt setup. Basically, I'm running this. Then I'm saying, okay, I want to take a look at the CPU profile. I'm filtering on a specific provider, which is Cluster API. And then I have profiles. So what I can see here is like, I have a profile at like 425, I have a profile at 430. I can click there. Let's hope it loads. And then I can try to figure out, in this case, for this profile, where are we spending our time? And you can do stuff like, okay, process next work item. So that's the point where we're taking, for example, a machine out of the queue. Then we're here still in controller runtime. Then here we are calling the reconcile function. And basically below here, we should be in cluster API code, and then zoom deeper into all of that and figure out, okay, I don't know, why are we spending so much time with regex and reflection and JSON parsing and that sort of stuff. Okay, I think I've hit all the points I wanted. What did I forget from this? Hope it wasn't too quick.
Since I'm host, I'll just say that was wonderful. There's a lot of chat. I think you were actually talking through a lot of it. Go ahead, Leonard.
Oh yeah, we can have to circle back to questions. I didn't read anything.
Well, I think what I was trying to get at is you ended up covering most of what we were curious about. So go ahead, Leonard.
Yeah, thanks. I was just sorry if I missed it, but I'm curious. Did you tweak any of the parameters for like parallelism or these rate limits or anything, or is this all defaults?
Currently, it's all defaults. Basically, we are mostly focusing on getting the basics in place, and then definitely all the things that we already discussed in the issues, like higher number of workers. I have already like 2 or 3 PRs open with ideas where we can tune, basically improve our code. So
awesome.
currently all defaults. Yep.
Thank you very much. Amazing demo.
Oh, also something that's super important to mention. So the Goofy provider right now is basically happy path in the sense of stuff is just happening instantly. And one thing that you want to do, of course, is add some sort of behavior. I mean, if you create a machine in an actual cloud, it doesn't happen instantly. And that of course leads to slightly inaccurate results. So I think we have a good starting point. We need a bit of polish and get into core copy, and then there is plenty of stuff where you can collaborate on improving various aspects of all of this.
Yeah, I chime in. Thank you again, Stefan, for preparing the demo. I think that this is what we're doing is getting the right tooling for doing the job, and then we have to do the job. So I think that we are down in a good path. This is the first time that I managed to have 400 clusters running on my machine, and it is kind of exciting. A lot of data and opportunity to optimization. And so, yeah, going back to my initial ask, is there any objection for folks if we can start moving this work into main copy repository under the /test folder?
Yassine?
Yeah, I think this is definitely great work. I think especially for providers, if we can reuse some of that work around dashboarding, that would be like ideal, so that we don't have to redo like the work twice, basically.
Oh, definitely the dashboard is a dashboard that works for every controller, developer with controller runtime. As soon as you have a real controller running, you can use it.
Perfect.
Yeah, and just a small addition. So basically the dashboard is me spending 1 or 2 days like just putting stuff on there that I thought is a good idea. I'm pretty sure we will make huge improvements once we actually pricing scale issues, because then we have like just a different point of view of what metrics you're curious about, or at which labels of which metrics you want to look at, and that sort of stuff. So I think that will get even better over time.
Yeah, there is also a question in chat from Vince, if we are going to add something in Prow at the end of this work. The idea is yes. We still have to figure it out how to get metrics out of a Prow job and make them visible offline in some other place. It is doable. We have to do a little bit of research. For now, we will use this interactively, but yes, at the end, we will have some Pro job running, possibly some alert on top of some KPI, like on, I don't know, average time to provisioning machine. So the Pro job will raise an alert if we see this degrading and stuff like that. This is future work.
Yep. Also adding to that, the dashboard I showed is just based on normal controller metrics. What we don't have yet, but is pretty high on my list, is also having a cluster API specific dashboard where we basically exclusively use cluster API stat metric stuff, where we see stuff like, I don't know, cluster. I mean, we have to see what we can do, but stuff like cluster creation takes this long, control plane creation takes this long, machine creation takes this long, and yeah, we don't have any of that yet. I mean, we have the metrics, we don't have the dashboards.
For the part that apply to, there is a question from Daniel, for the part that apply to controller runtime, can we maintain them in controller runtime itself? Yeah, this is something that we can consider. For now, we are just researching, developing, and then we will figure it out if there is a good way to contribute there. Kind of makes sense.
Super fun. Thanks, Stefan and Fabrizio. If no more follow-up questions, unfortunately, we'll move on from this awesome demo.
Okay,
Joe, it looks like you want to talk about, oh, go ahead, Fabrizio.
It seems to me the comments were all positive and all about what we can do with this. So we can consider that we can start moving the code as soon as we're ready.
I did not see any negative comments.
Thank you, everyone.
All right, Joe, you want to talk about patch releases, looks like.
Great. I have to follow up with that. Are you kidding me?
Yeah.
Cool. Yeah, so just a real quick, I think everybody's somewhat aware, or most people are, we were supposed to have a release on Tuesday. There was an issue, two issues actually, but the blocking issue was Prow was having issues picking up new jobs. So I think we didn't have any tests running between Monday and Tuesday. So the CI team made the call that we're not ready to go. And at the same time, there was an issue that popped up, issue 8764 right there, which was related to kind images with a 127.2 cluster. And so there's work being done there to mitigate for a 1.4 release, but it will need, there'll be some work being done to make sure that it's handled for 1.5 release coming up. The beta in 1.5 should be June 27th. So with those two things that kind of came up, instead of trying to rush and get everything ready for today or tomorrow, we kind of made the executive decision to push the release to make sure we got enough greens and enough conformance passing to next Tuesday. So June 6th will be the 1.38, 1.43 release. That announcement has been made in the Slack. We still have to push it out via the mailing list, but we'll be working on that here just right after this. And then one other thing to quickly call out is that we do keep release team meeting notes and have for a while. So there's that Google Doc there. And then each meeting has notes, as well as in most cases videos, if I can get them uploaded to YouTube in time.
Awesome. Sounds like a ton of value all you folks are bringing to Cluster API. So this is great.
Mainly trying to knowledge share so everybody knows how things work. Yeah.
All right, wonderful. Any questions for Joe on any of that? Looks like we've got lots of good links in the doc, so you could follow up later if you'd like. Okay, great. So Killian, who is no longer on the call, provided a bunch of Slack links to help folks retroactively see what was done to investigate recent end-to-end flakes. I think I'm not going to click on each of those, but I'll happy to narrate those and encourage anyone who's interested to look at those and then just put into your brains. The next time you see a flake, look through the agenda item and find this, and this may help you debug the next flake if you don't keep this in your personal favorites. Does anybody want me to click through any of those while I'm screen sharing? Okay, cool. Thanks, Killian, for adding all that. All right, Chris, you want to talk about a cluster cache reconciler issue.
Yeah, this is not like, it's quite a small agenda item, probably something I could have sent in Slack as well. I'm looking for someone who is familiar with this part, like this part of the CAPI controllers, specifically because I'm running into problems. So like what Rancher does with CAPI is we allow for essentially a full cluster lifecycle operation. So this is including things like etcd snapshot restoration. And I'm finding that when I do etcd snapshot restoration, restorations on a cluster, the CAPI controllers tend to just stop functioning for that cluster until the caches expire. And so right now I've got a pretty hacky workaround in place that is shimming my own, like it's basically a cluster cache reconciler into place to force CAPI to recognize that my caches are deleted, or the caches for that cluster should be deleted when we're doing an etcd restore. But that's not ideal in the long term because I'm trying to move towards just consuming the controllers as they come. And so I'm looking for someone who, or if anyone knows who might be able to help me out with this. I mean, at the end of the day, if all it is I just have to open a PR that tries to add functionality to handle this case, I'm happy to do that. But you know, if maybe I'm like missing something and like I'm doing this wrong, I mean, that's, you know, it's a very real possibility there. And if there's no responses here, you know, that's fine. I will, you know, yeah. So I saw Vince. Yeah, I can totally, and I have not opened an issue yet, which is what I was planning on trying to do it, but I tend to be someone who likes to open issues with as much, I guess, fidelity as possible. But so I didn't want to rush it or get a stub issue out. And then I do see, I think, hands raised. I don't know what the normal procedure is here. Am I the one who would call on hands? Okay.
Yeah,
so I guess
we're all friendly here. Just go ahead and call on folks.
Okay, awesome. So yeah, I think Fabrizio, I think I saw your hand go up first.
You're muted, Fabrizio, if you're talking.
And Fabrizio just wrote me that his Zoom is going crazy. So it's probably not.
Just seeing your first.
Yeah.
Okay, I'll go first meanwhile. So I think, yeah, just whenever you open an issue, please, like, if you can specify the use case, I think that would be great. Like, is it like an in-place restore? Is it like you're trying to restore to a new cluster and so on and so forth? Because depending on the use case, it might have implications on CAPI and even on providers. Some providers, you might see issues if you're doing a restore on like a blank new cluster. So I think, yeah, just like a spec out of what we're trying to do.
Yeah, for sure. I can kind of go over it. So I mean, I guess for a little bit of context that will also be included in the issue. So we have our own sort of cluster API provider on the Rancher side of the house that provisions our K2 and K3s, which are our distributions. But we like, it's funny because Tappy wasn't necessarily designed to do these like full cluster lifecycle management. So I've had to kind of like come out with my own workarounds to get it to work. So there's probably like assumptions that I'm making here or like design decisions that I've made so far that may not necessarily be what the rest of the upstream would, I guess, expect me to be trying to do for lifecycle management. So I'll give as much context into the issue as I can to sort of give what I'm doing and how my provider works. It's not yet, I mean, it's in our code base, but I'm working on pulling it out so that so essentially so you could run it with the controllers without having Rancher around, because that's actually one of my end goals, but that's, you know, it's going to be a little bit until I can do that.
Maybe you can hear me now.
Mm-hmm.
Yes.
Yeah, so first of all, yeah, thank you for opening the issue. This is super important. Cluster cache tracker is an important bit of code. For if you open the issue, we probably, me, Stefan, a couple of other will follow up. We are not doing really strange things with regards to workload cluster. We are just opening a client and every 10 seconds, if I remember well, doing health check if there are just entering errors. So yeah, we will figure it out if there is a way to recognize cluster has been restored, but I'm also interested in understanding all the things that we are doing, because from what I can hear, they seem valuable for everyone.
Yeah. And so I am familiar with the health checker that exists in, I think it's the cluster cache reconciler. But we have this weird, so we are, so like one of the requirements currently with cluster API is that you must be able to dial the downstream clusters API server from the cluster API controllers, and our architecture does not require that. So we actually have an authentication proxy for our API servers that then allows the cluster API controllers to dial the downstream clusters API servers, but without having to establish a connection directly downstream. And so that throws off things like health checks and stuff because it's a live endpoint. It's just, you know, it's because it's just a proxy. So yeah, like I think there is some like context here that I'll be trying to open up or trying to give, you know, just from the perspective of, you know, what we're doing and trying to give as many hints to say, hey, maybe you're not doing this, you know, like for someone to come and tell me, hey, maybe you're not necessarily doing this the right way. And so we'll see. And then Stefan.
Yeah, just adding to that. I think, yeah, you probably looked at a code, a cluster cache tracker, where he opens the client informer and has it have check if you need for every workload cluster, and then we're just watching on stuff. So depending on how it fades exactly, and I mean, there are different ways as it could stop working, right? I mean, it could be on one side that, I don't know, the cluster API controller just overall reconcile those clusters not anymore, I don't know, or that you're not getting any new events from the watches that we have against the workload cluster, and that problem could be either somewhere in the cluster cache tracker, or it could be on the underlying controller runtime or client Go layer where we have those watches.
Yeah.
Maybe those watches get killed when you do the etcd restore, because I don't know, you have watch bookmarks and stuff in watches. So I don't know, maybe it's not good if that stuff is getting reset and controller runtime or client Go doesn't deal with that correctly. So yeah, I would say let's open the issue or whatever research you want to do before.
Yeah,
and
for
then,
sure. No,
we might have to dig very deep and try to reproduce it in as simple as possible environment.
Yeah, that's actually one of the things is, you know,
things go wrong.
Yeah. With like the limited number of hours in the day I have, you know, it's been difficult because I've been slammed for the last couple of months on our own issues. So, I mean, that's why I actually, like I said, you know, I like to open my issues with full fidelity, like basically like delivering things on a silver platter is my goal. So I need to do a little bit more investigation to really nail down exactly what's going on here. The issue was kind of like thrown over the fence to me from someone who used to work at Sousa Rancher who left. And so now I'm kind of just picking up the pieces. And you know, with the requirement that like we have from like, you know, right now we basically are importing the controllers and then establishing, just running all the registers on our own. Our goal is to be able to just run the controllers in a pod within the management cluster, which is what the traditional layout or the traditional architecture is. So that's why I'm kind of trying to bring it up here. So yeah, I'll get that issue opened up, by the end of the week, and I'll send it over in the Slack, the Slack channel, when I get it open. So. Yeah, and I do really appreciate everyone taking the time to respond to me on this. So, thank you.
Cool. Thank you for sharing. Sounds like there might be some interesting discoveries there. All right, any last minute agenda items? We probably don't have time, so shouldn't have opened up for that. We'll go to provider updates because we've got a couple. Cecile, you want to talk about CAPZ?
Yeah, thanks. This is very early, but we're seeing some lots of jobs in our test grid dashboards for CAPZ failing over the weekend, since May 27th to be precise. I was wondering at first if this was maybe related to the CI failures that the CAPI releasing was investigating, but it seems like it might not be. I think right now my current hunch is that it's related to the Calico 326 release, which came out around that time. Don't have a root cause yet, just an FYI in case other providers are seeing this. Yeah, we'll keep you all posted.
Anyone else see anything similar to this in your provider CI? Stefan?
Yeah, just to confirm what Cecile, I think, was already suspecting. I think the issues we had in core copy were definitely unrelated. I mean, one issue was obviously that Pro was entirely down. And currently we only have one issue remaining, and that is that the 126 to 127 test, upgrade test is failing, or the conformance test after that is failing. And the root cause seems to be that they changed something in the kind image from C groups or something. And then they only pushed a new 127.2 image. So that's why only this job is affected. But that seems like a totally different issue. And otherwise, everything is green. So yeah, I don't know. We probably still use KindNet everywhere. So we have a different setup regarding Calico or not Calico.
Cool, thanks for the call out. And we are at the end of the formal list. We've got 9 minutes. I can give that back. Any final remarks? Okay, this was a fun one. That demo is going to be on YouTube soon. Happy week, everyone.
Thanks, Jack.